I visited it just literally a few months before it collapsed. And
Wow.
it was around for decades, and it's the one that was used in the movie Contact with Jodie Foster when she was like listening to aliens, and also was James Bond. Which one was it? There was James Bond was
GoldenEye.
Pierce Brosnan. He was Yes, exactly, that's the one, and he was running on that bridge, and everything was like falling down and collapsing. By the way, when I was there, they told me that when they were filming that movie, he actually he has height anxiety, so he couldn't actually run on that bridge. So I was a stunt double, and I
Oh
was
wow.
actually walking on that bridge. So I felt like I can do something James Bond couldn't do. So that was pretty cool.
What's up, everybody? From Nautilus, I'm Brian Gallagher, and you're watching Behind the Scenes. Today I'm speaking with Katia Moskvitch. Katia is a theoretical physicist and the author of the book Neutron Stars, The Quest to Understand the Zombies of the Cosmos. And among other jobs, she has worked as an editor at Wired and as a science reporter for the journal Nature and a columnist for BBC Future. Her recent story in Nautilus was Giant Zombie Atoms of the Cosmos. In neutron stars, astrophysicists see a form of matter like none other. Katya, thanks for joining us.
Hi, Brian. Hi, everyone. Thank you for having me.
So, to start off, would you mind summarizing your intellectual and academic background, as well as how you got started in science journalism?
Sure. Wow. Okay. I hope I can fit it into a minute or so. Well, I did my bachelor's actually in engineering, mechanical engineering, as aerospace specialization, and I wanted to be an astronaut. Always been fascinated by space, so that kind of didn't happen for a variety of reasons. So I went into science journalism instead, and did a master's degree in that. But then I found myself writing about astronomy and physics a lot, kind of way more than about dinosaurs or biology or whatever. So I was writing about it for years, for BBC, and then for New Scientist as a freelancer and Nature and stuff like that. And I thought, I'm writing all these fascinating stories, but I understand maybe 25% of what I'm writing about. That's not on. That's not cool. So I decided to do a physics degree as a graduate degree. So I did an MPhil in theoretical physics at King's College. I knew I wouldn't go into academia, so that was purely kind of to help my journalism, and I continued writing about astronomy. And around the same time, I also started writing a book, as you said, Neutron Stars, because I don't know, it's a fascinating object. There's lots of other fascinating things in space, and neutron stars are just one of them. So that's how it happened.
What drew your interest to becoming an astronaut? Was there something that you witnessed in childhood, or anybody you knew who was an astronaut that got you passionate about the possibility of that path?
Both. I don't know. I just always wanted to go into space, and it just so happened that in my high school in Montreal, I suddenly saw a portrait of Julie Payette on the wall, Canadian astronaut. And I wrote her a letter. I think must have been 15 or 16 at the time. And I wrote her a physical letter at the time and asked, what can I do? I want to be an astronaut just like you. And so she went to the same high school as me. And she replied, believe it or not, she sent me a Christmas postcard back with a Canada arm and a Christmas tree on the card. I still have the card. And she said, well, you have to go into, science or engineering. And that I really wanted to pursue that. That's how I ended up in engineering. But then I decided that actually I wanted to write more than be an engineer, because I thought being an astronaut, that's probably, as I said, probably not going to happen. One of the reasons was because of my vision. I wanted to be a jet pilot, but then my vision is not 100%, so that didn't happen. But
Mm.
writing about science, writing about astronomy is close enough, because you still get to explore space in an indirect way, but it's still pretty cool. And I do have a telescope now at home as well, so that helps.
Nice. Well, I mean, do you think that going into space is still something you might want to do? I mean, the commercial space industry is kind of blowing up. Maybe that's not the best choice of word, but yeah, it seems more and more people are being able to go up without necessarily needing to have a huge background in being an astronaut. With companies like SpaceX and stuff.
That's very true. Well, if I suddenly win the lottery, or if Elon Musk watches this interview and contacts me on Twitter and offers me to go to go on one of his rockets, sure, absolutely.
Um, right. So your story that you wrote was the atoms of the cosmos. Do you want to give us a brief summary of that story for our viewers who haven't read it yet?
Sure. So the article I wrote just recently deals with just one tiny aspect of neutron stars, and just maybe we should kind of rewind a bit though, because I would assume that some of the listeners also don't know what neutron stars are, and I wouldn't be surprised because I myself didn't really know. Maybe I heard the name or the term, but we are so used to hearing about black holes, for instance. They are everywhere, right? Everybody knows about black holes. Kids know about black holes pretty much in detail. And that's great that they are fascinating. But if you think about it, black holes, what are they? They're not matter, they are radiation. But neutron stars are these amazing objects. They're really tiny, okay? They're like, well, I'm in Europe, right? So it's about 20 kilometers across. What would that be, Brian, in miles? 20 kilometers, 15 miles or something?
A mile is longer than a kilometer, right? So I'm going to say it's a little
Oh,
bit
okay.
more.
The other way
I
around.
think. Yeah. I'm not sure. I got
Well,
to check
anyway,
that
it's
again.
basically it's the size of an average city. So maybe if you can imagine, I don't know, Chicago, and you curl it up into a ball, and it's that tiny ball, okay, the size of an average city, in space, spinning around itself on its axis, giving off radiation in the form of radio waves, typically, not only, but typically. And we can detect that radiation using our radio telescopes. And that's a neutron star. And they don't appear out of the blue, of course. They basically appear when a supermassive star, way bigger than the sun. So the sun is actually not so massive at all. But if you take a much bigger star and it explodes, it dies. Okay, it dies and it explodes in a supernova explosion. And what stays behind after the explosion is this object, this tiny, tiny sphere, neutron star. And we know, we understand why it emits the radio waves, how it appears, why it appears. We understand the stages of nuclear fusion and how the star kind of lives, in quotation marks, and then dies. But what we don't know is what's inside those objects. And in my book, I talk about neutron stars, like all the aspects of them and how people have been studying. Actually, the book is more about people rather than, as much about people as it is about science. But this particular article, if anybody does want to read it, it deals with one of the most enigmatic aspects of neutron stars that we still don't know is what inside of them. Because, basically, even though we know that what stays behind after a supernova explosion is iron, okay, because iron is like the last element of nuclear fusion. So we know that the outer shell of a neutron star, of this tiny thing, is made of iron. As you go deeper and you get to the inner core, things get super weird and we don't know what's inside. It could be completely exotic matter that we cannot really reproduce on Earth. So we have theories, and we try to understand using a variety of techniques, and that's what I kind of talk about in my article. But I would really love to be there, to be around when we actually understand what's inside. And I have a feeling that we're not gonna know very soon, maybe one day, but it's still going to remain a theory because there's no way we can actually fly to a neutron star and kind of probe the insides. So
Maybe I missed it in your description, but why exactly are they called neutron stars?
right, well, because they're made of neutrons. So effectively, um, the pressures are so enormous that atoms break down. The nuclei of the atom breaks down completely, and the protons, so the nuclei are protons and neutrons, and there are also electrons floating around, but the protons get merged with the electrons to form even more neutrons. So at the end, there are just so many neutrons in those objects, and I'm talking about now the kind of the outer core, as we call it, because if you imagine this object, it's sort of like an egg. So it's got the outer shell made of, we think, of iron, and then the outer core, which you can refer to as an egg white, and that's all these neutrons floating around, and we refer to this phase as nuclear pasta, because under all these pressures, it starts forming weird shapes, and we call them lasagna, gnocchi, spaghetti. Very weird, but still kind of understandable. And we can understand, we can study it. We know what we're talking about, what we are dealing with. But as you go deeper, the neutrons, now we have superfluid kind of neutron soup. So it's basically just neutrons. But as I said, as you go all the way down, all the way to the center, to the inner core, that's where it gets super weird, because every neutron, that's not the end of it, right? Like inside a neutron, you've got quarks, you've got even tinier particles, and we don't know whether the neutrons actually stay intact in the inner core, in the yolk, so to speak, of the neutron star. If they stay intact, just packed ever so tightly, or maybe they also break down, right? And they turn into this weird quark jelly. We don't know. This is what we're trying to understand.
Mm-hmm. How did you get interested in writing about neutron stars?
Right. Well, that was completely by accident, actually. That's when I wrote my book. So this article was inspired by my book that I wrote. I think it was 3 years ago now. It was pre-COVID. So I was covering. I think it was 2017. Maybe some of the listeners may remember. There was this really cool story about a collision of two neutron stars, and this gravitational wave detector, LIGO, in the US, and another one, Virgo, in Italy. They detected gravitational waves. So basically, when you throw a stone on a lake, you get ripples on the surface. And it's the same in space. If you get two really dense, really massive objects that smash into each other, they produce these ripples in space-time, and we can detect them. And they've been theorized for years, but we only managed to detect them for the first time from neutron star collision in 2017 in August. And I was covering that story. It was super cool. It was completely blowing story at the time. And I remember after writing it, I got a LinkedIn message from some guy, and it was like, he said that he was a publisher or an editor rather at a publishing house, and he wanted me to write a book on that, or anything like related to neutron stars or whatever. And at first I didn't even I didn't pay any attention to that message, because on LinkedIn typically I would get some weird marketing promotions or something. So I thought that must be spam. But then I came back to it, and actually it was legit. It was a real offer to write a book from Harvard, Harvard University Press. And the editor, he's amazing. We're still in touch. So he asked me to indeed explore this a bit further. Beyond that particular story, I knew nothing about neutron stars, right? I only knew that they, smashed into each other and produced gravitational waves. And I started digging, and there were not much, there was not much information on them. There was a lot, as I said before, on black holes, but neutron stars, not really. Maybe some school books. And I just thought, wow, that's unbelievable. They're so cool. They are actually the last bus stop, you can say, or the last form of ordinary matter before it collapses into a black hole. They are the densest objects that we know of. And when I say dense, actually, I'm not sure if everybody understands what that means, but basically, if you imagine, as we said, a tiny ball, right, like 20 kilometers across, and they are heavier than the sun. And the sun is huge, right, like way bigger than the Earth. And you take the mass of the sun and you kind of put it all, you shove it into this tiny 20-kilometer across sphere. That's how heavy they are. Some of them are heavier than 2 solar masses, or masses of the sun. And that's what density actually means in this particular case. So when 2 dense objects collide, as we said, they produce gravitational waves, and this is only one of the cool things that they can do, because there's so much more about them, some of which we do know, some of which we don't know. But basically the whole book, I was discovering and uncovering new things, and it was a travelogue, so I traveled to all those observatories, actually, again, pre-COVID, so I was very lucky. It was literally before COVID started. So
Fascinating. How did you start thinking about how to write that book? I mean, how did you want to begin it? I mean, after traveling to so many places, how do you decide like where to begin?
yeah, that's a good question. Well, I kind of had a plan, but at the end of the day, the book kind of follows a narrative from the beginning, like how they were discovered. And of course, at the very beginning, they were theoretical objects because they're so tiny and you cannot see them with optical telescopes at all. They don't give off any light, any heat, whatever. You cannot see them at all. And we didn't have radio telescopes until beginning of 20th century, really. So in the very beginning, we knew about the neutron. We knew what the neutron was, but that didn't really help. And then in the 1930s, there was this connection that was made between supernova explosions and something that was left behind. So there was a really weird, eccentric astronomer, super cool guy, genius, called Fritz Zwicky. He wrote that paper in the 1930s, and he said that, like, he thought that in a supernova explosion something must be left behind. And at first people didn't really pay attention much, and then some did, and but still it took a number of years for these objects to while they were still kind of theoretical. People were kind of studying them a little bit, but not so much. And then in 1967, I'm sure many listeners have heard the name Jocelyn Bell. She's amazing, and I met her at the time in 1967. She was a PhD student in the UK, and she was actually studying something completely different. She was actually creating an array in Cambridge, putting poles in the ground by herself and connecting them, like lots and lots of wooden poles, connecting them with copper wire. She was studying interplanetary scintillation from quasars. Quasars, which is discovered another object in space that we study with radio telescopes. Anyway, and suddenly she discovered a really weird signal. And it was all analog at the time, so it was like a printer and red pens that kind of were squiggling these signals on meters and meters of paper that was coming out of these printers. And she was studying them manually. She was looking at them like every day and checking them to detect new quasars. And so one summer night, she sees a really weird squiggle, and she was like, what is that? Like, that's so weird. Like, this must be some interference, maybe a nearby tractor or a car or what have you. And then she didn't tell anybody at first. And then she, in a few months, she kind of told her PhD supervisor. And then she noticed another squiggle again in December, so a few months later, right? And they thought maybe it's aliens. So aliens was a real, believe it or not, like a real hypothesis at the time. Like, maybe it's aliens. Oh my God, what are we going to do? How are we going to tell the world? So they were freaking out and they really didn't know what to do. So it was super secret and only like a handful of people knew about it. And then yeah, and she was a bit upset about it. Like she told me, I met her in Oxford. She's now a professor, an honorary professor in Oxford University. She's super cool, super nice lady. Anyway, she told me that she was super annoyed that a bunch of aliens kind of signaling the Earth, our completely weird tiny planet, were trying to hijack her PhD defense, her PhD project. And she was like, "What the hell?" Anyway, then she actually managed to detect two other signals from other parts of the galaxy, and so that was clear that it was not aliens, signaling from different parts simultaneously. Like, no way. It was a new astrophysical object out there. They didn't really know what it was, so they wrote a paper and they hypothesized that it might be a neutron star or maybe another object, but maybe they did mention a neutron star. And then when they presented it, there was actually a science reporter, a science journalist from the UK, who gave it a name, pulsar. So pulsars are neutron stars that give off. Now we know that they give off these radio waves that we can detect, and when they arrive on Earth, they arrive as pulses because when you have a radio dish and you have this object that spins and gives off radiation from the poles, from its magnetic poles, and if you can imagine a lighthouse at sea, it's pretty much the same kind of scenario, right? Because when a ship sees a lighthouse, it just sees it when it spins, like whoop, 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 like that, right? And it's the same with the pulsar. Our dish will detect the pulse when it's in the, so to speak, field of view of the Earth, right? So it spins and we detect pulse, and then again pulse as it spins, and so on. So that's why we call them pulsars. But not all neutron stars are pulsars. Some of them are magnetars. They are the most magnetic things in the universe. Again, fascinating. And in my book, I talk about all the different types of neutron stars. All of them are super cool. So I hope that answers your question. I don't really remember what it was anymore.
Is that why when Jocelyn, right?
Yeah.
Jocelyn Bell, you said she saw signals coming from two different parts of a galaxy, and that's why it couldn't be aliens. How did she get a signal from two different parts of a galaxy? Was that because of the spinning pulsar?
Yeah, it was just a different pulsar. Exactly. So it was just a different pulsar.
Different neutron star.
Different neutron star pulsating from a different part of the galaxy, but with the same signature, with the same type of signal that she received from a completely different place. So she kind of knew it couldn't be a second bunch of aliens also signaling the Earth at the same time. That was just weird. So
yeah, that would be wild. So how did what led you to write about her and her research for this Nautilus piece?
Well, that was just the beginning, right? You asked me how I structured the book, right? So that was the beginning of neutron star research. So 1967 was the year when we actually discovered them, and that was unbelievable because we really thought, like the astronomers at the time and physicists at the time, they really thought that these objects, if they do exist, and okay, some people already thought pretty much that they existed because it was proven mathematically that after a supernova explosion, something must stay behind, blah, blah, blah. Indeed, they are probably there, but we'll never discover them because they don't give off any optical light. So how in the world can we ever see them? And then Jocelyn Bell comes along and discovers the signature pulse radio waves from them, and they made the connection, and they start there was the golden age of pulsar astronomy. They discovered so many of them, and I think, if I'm not mistaken, there are about 3,000 of them that we know of now, roughly, in our galaxy alone, and that's pulsars because we can detect them, radio pulsars. But neutron stars, many more, because not all of them actually spin, or even if they do spin, maybe they don't spin in a way that we can detect them from Earth, because maybe they spin in a different field of view, right? So we don't detect the pulses. Who knows?
So you mentioned magnetars. How many other kinds of neutron stars are there that we know about?
Right. Well, there are also those that radiate in X-rays, and actually, uh, for the article I wrote, when we're trying to understand what's inside of them, we are using a really cool instrument that was launched just a few years ago to the International Space Station called NICER, and that instrument is looking at neutron stars that radiate in X-rays. So it studies specifically, it uses X-ray astronomy to study X-ray hotspots, so to speak, on the surface of these objects. And then there are those that also radiate in gamma rays, and they are usually neutron stars. They exist in binary systems, so with a companion. Sometimes they behave really weirdly. They can kind of stop spinning and then get revived again, thanks to the companion, and then change the way they radiate. So there are all sorts of different weird behaviors. And I actually urge listeners, if you want to just kind of Google neutron stars, like weird types of neutron stars, you'll see amazing pictures, not real pictures, of course, but kind of images that we're trying to reproduce, like how they would look like. And there are all these different types of neutron stars that you can at least see visually what they look like.
What was your favorite place to visit, favorite observatory in the course of reporting for your book?
Well, as you can see on my T-shirt that I'm wearing today, it's Arecibo. So Arecibo was probably the highlight. Doesn't exist anymore. So I don't know if, again, if anybody in the audience remembers a few years back, sadly, this amazing, amazing telescope collapsed. And I visited it just literally a few months before it collapsed. And
Wow.
it was around for decades, and it's the one that was used in the movie Contact with Jodie Foster when she was like listening to aliens, and also was James Bond. Which one was it? There was James Bond was
GoldenEye.
Pierce Brosnan. He was, yes, exactly, that's the one, and he was running on that bridge, and everything was like falling down and collapsing. By the way, when I was there, they told me that when they were filming that movie, he actually he has height anxiety, so he couldn't actually run on that bridge. So I was a stunt double, and I
Oh
was
wow.
actually walking on that bridge. So I felt like I can do something James Bond couldn't do. So that was pretty cool.
That's a great feeling. Yeah, yeah, still my favorite Bond movie for sure, GoldenEye. And that I remember the moment when I realized that that thing was Arecibo, and I thought that was super cool to make that connection, because I realized that much later when I got interested in science after I had watched that James Bond movie like over and over again when I was a kid. Really cool.
Yeah,
All right, I mean,
it is
to
amazing.
close out, do you want to tell our viewers where they can find you online? Do you have social media accounts they can follow, or website where they can go check out your work?
Well, I mean, I would, if people are interested in neutron stars, I would recommend you read my book. That would be an
Of
honor, and let me know. If anybody does read it, I would really love for you to get in touch via Twitter. I'm on Twitter. I'm not so active anymore, but I do reply to messages. And I'm actually looking for an idea for my next book. So if anybody would read it and let me know what they think I could write about next, I would be, yeah, I would definitely reply to that.
What's are some of the ideas that you have going now for your next book? Do you know?
Well, I'm kind of thinking about dark matter. I think there's so much. Actually, there's a chapter in the book on neutron stars, believe it or not, that also deals with dark matter, which is pretty cool. But I'm not going to say anymore. But there's a really cool connection, and it's amazing. And when I was writing that particular chapter, I thought maybe I should explore it further. I think there's enough material for an entire book, so that could be it.
Excellent. I look forward to that if that ever comes out, if that ends up being the focus of your next book. Excellent.
Cool.
Well,
Thank you,
thank you
Brian. I'll
so
let you
much,
know.
Katia. Excellent. Thanks so much for joining us. Really appreciate the time talking to you.
Perfect. Thanks. All the best.